This short video documents the ongoing development and progress I've made on my major design project so far. Here I present the initial hand-drawn sketches that form the foundational concept of my design. This is a 3D printed prototype that represents a tangible version of my design idea, allowing me to visualize the form and function early in the process. This is the initial digital model I created using Tinkercad, which helped me experiment with the proportions and basic structure. Shown here are the work health and safety signs that are strategically positioned throughout the workshop to ensure a safe working environment. Here I am shown putting on and wearing the correct PPE required to operate in the workshop. As the first step in my practical design process, I needed to reduce the thickness of the jarrah timber. I used the bandsaw to carefully cut the timber in half, achieving the required dimensions. After resizing the timber, I precisely measured and marked out the layout for the coloured inlay strips, preparing them for accurate cutting. Using the drop saw, I meticulously cut the timber planks to the exact length required for the design, ensuring uniformity and consistency. Following the cutting process, I used the disc sander to smooth all edges, eliminating any roughness and preparing the planks for further refinement. This sanding was in preparation for using the table saw, which I then used to slice the planks into thinner strips that would form the playing surface of the chessboard. To assemble the strips, I used Type 1-3 water-resistant wood glue, ensuring strong adhesion while maintaining the integrity of the join. I utilized the Fettstall domino joiner to create precise mortise in the strips, which allowed me to insert domino tenons to enhance the structural stability of the board. Once the domino joints were set, I proceeded to re-glue the strips, aligning them carefully to form the final surface of the chessboard. I used 4 jarrah planks to construct the main cabinet box, beginning by cutting them to the correct lengths using the drop saw. I then shaped the edges of the planks using the finger joint jig on the router table, producing interlocking joints for added strength and a decorative finish. Once the joints were routed, I once again used Type 1-3 glue to bond the pieces together and secure the joints using corner clamps to ensure accurate alignment while drying. After the glue had fully cured, I used the hand rebate cutter to create a rebate along the inside base of the box, allowing for a flush fit for the bottom panel. I also used the router table to cut a rebate around the chess and backgammon borders so that each would sit neatly and flush within its designated area. I progressed to sanding all components, beginning with 80 grit, then moving to 120 grit and finishing with 280 grit sandpaper, ensuring a smooth, defect-free surface on both boards and borders. With the surfaces prepared, I used Type 1-3 once more to bond the border to the chessboard, taking care to achieve clean lines and a strong hold. For the backgammon board, I used the laser cutter to accurately cut out uniform colored triangles, achieving a precise and professional finish. These colored triangles were then carefully arranged and glued into position to complete the backgammon pattern. I then attached the border around the backgammon board using Type 1-3, maintaining a cohesive and refined appearance consistent with the chessboard. For the sliding mechanism, I used Goliath 450mm draw runners. These were installed with precision, using the supplied screws to secure them to the frame. I also mounted drawer brackets to the back of the backgammon board, allowing the board to smooth slightly in and out, completing the integrated mechanism. The final touches and assembly of my complete product will be finalised in the upcoming school term.